Hey guys, welcome to the channel. So in this video we are going to discuss another puzzle, and the name of this puzzle is the plane in the wind. Okay, name of the puzzle is the plane in the wind. So let's understand what exactly the problem statement says, then we'll come to solution. Okay, so an airplane flies in a straight line. Okay, it flies in a straight line from airport A to airport B, and then back in a straight line, back again in a straight line from B to A. Okay, it goes from point A to B, point A to B, it goes from A to B and again comes back from B to A. It travels with a constant engine speed. So engine speed is, we have our speed uh, is constant, let's say S, it is constant. Okay, and there is no wind for the moment, so wind speed is 0 at the moment. Now, will the total travel time for the same round trip be greater, less, or the same if throughout both the flights a constant wind blows from A to B? Okay. So now, if we have a wind that is blowing from A to B, wind blowing from A to B, let's say the speed of wind is W, then will there be changes in the travel time? And if there will be changes, what it will it be greater than as usual, less than or as usual, or will it be the same as it is? Okay, so let's say we have a travel time which is t. Travel time is t. Okay, so this is the problem statement we are given with. Okay, pause this video for a minute and try to think on it and see if you are able to solve it on your own. Okay. Okay, all right, guys. So let's see how we can approach to solve this problem. We have everything given with us. We have speed given, that is constant. We can assume it as s. Okay, and we also assume the time traveled is t. And if we assume the distance between A and B is given as d. Okay, so what can be your travel time? Travel time, that is t, can be given by total distance traveled in one way, that is traveling from A to B. It will be d by s, distance by speed. This is the basic formula we are already aware of from our higher schools. Okay, so the travel time from point A to B for a flight is given by d by s. What will be total travel time for the flight from, that is from A to B and then coming from back from B to A? The total time will be, let's say represent this by capital T, will be 2d by s. This is the total travel time we are given when there is no wind blowing. Okay, now we have a case, now we have wind blowing from A to B with some speed, which we have assumed as W. So speed of wind is W and speed of flight is s. So going from A to B, what will be our time? We have distance as d by speed. Now the speed will change, we'll have a relative speed, not relative, the total speed will change. Since wind is blowing from A to B and flight is also going from A to B, the total speed will sum up. So we'll have our speed as s plus W. Okay, when going from A to B. Now when the flight comes from B to A, when it is in opposite direction, flight is coming in opposite direction, we will have our speed as s minus W. Okay, this is basic calculation from higher school. I hope you are aware of this. Okay, so now here when the flight travels from B to A, the time taken would be d by what this will be s minus w. Okay, we have this from A to B time taken, and we have this from B to A the time taken. So now the total time taken will be what? Total time taken, let's say this is t with tw when wind is present, d by s plus w plus d by s minus w. We can do the calculation s plus w and s minus w. We have we can take the d common. Okay, we will have s plus w plus s minus w. Sorry. Okay, we can do cut them, and then finally we will have 2ds by s square minus w square. The denominator will be s square minus w square. I hope you are aware of the formula a square minus b square, which is given as a plus b into a minus b, and this is in the same format. Now in the first case we have our total time travel given 2d by s. In the second case we have our total time travel given 2d into s by s square minus w square. So let's convert this term in terms of by leaving 2d above and removing s from the numerator. Okay, so if we solve this, we can divide numerator and denominator by s. So here we will get s square by s minus w square by s. Okay, now we have 2d by s minus w square divided by s, and the earlier time we had is 2d by s. Now if you see here, the numerator part is exactly same. Okay, and the denominator part, here we have denominator part is s, and here the denominator is decreased. Now whenever the denominator decreases, the overall value of the fraction increases. Okay, so in the case when the wind is present, we can say when wind is present. Okay, the total travel time for round trip is always greater than what? The normal travel time when wind was absent, when there was no wind blowing. Okay, so this is how we can solve this problem. This is a basic very easy problem. We just have to follow some calculations related to time, distance and speed. Okay, I hope you were able to follow along me. Okay, and I hope you enjoyed the video. So that's it for this video, guys. Thank you. We'll meet in the next video. Bye.